Hi, my name is Marty Shaw. I'm a science teacher at the Delphian School, and this is my colleague, Diego Martinez. Hello. And we have James off handling computers and handling questions. Here's James. So if you have any questions, hit your Q&A button and send them in to James, and he will relay them to us. And we'll see if we can answer some questions and get some things cleared up. So I just wanted to go over some things about basic chemistry. This is some of the data is from this book, Everyday Chemistry by Heron Books. And you can get that online, and you can do some of these experiments if you'd like. So the first thing we're going to talk about is we're going to talk about atoms. So atoms are very, very, very tiny pieces of matter. And everything is made up of atoms. There's a joke, never trust an atom, they make up everything. And they do make up everything. They make up bodies, and they make up air, and they make up plates, and they make up cables, and they make up just about everything you can think of. They don't make up thoughts or ideas, but anything that you can see or feel or touch, atoms are made from atoms. And
Marty, let's hear that joke one more time. Just so the kids can repeat it.
Okay, here it is again. Never trust an atom. They make up everything. Okay. So anyway, we have lots of things. Here is a table of the elements. So elements are the names given to different types of atoms. So atoms have 3 parts. Protons, which are these guys that have a plus on them, that are in the middle of the atom. And the neutrons, which are also in the middle. And these electrons. Now, these elements, you read this from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These numbers tell you the number of protons that an atom has. And if you'll notice in this picture, the number of protons for this atom is 3, and it also has 1, 2, 3 electrons. It has the same number of electrons. Atoms are always balanced. They have the same number of positive protons as negative electrons. And so here's lithium. There's lithium. That's number 3. Can you see that? That is what this atom is a picture of. It has 3 protons. If it had 4 protons, it wouldn't be lithium. If it had 2 protons, it wouldn't be lithium. Each of these atoms, each of these elements have a certain number of protons. That's called the atomic number, and that determines what it is.
Okay, Marty, what do we use lithium for?
We use lithium for batteries. You might have heard lithium batteries. Those are in your cell phone. What else do we use lithium for?
Lithium is one of the main things that comes to mind. They have, I think it's used in some pharmaceuticals. But yeah, and it's a really light atom. That's why it's used for batteries.
Right, it's the 3rd lightest. Hydrogen is the very lightest, and then helium. Helium is used in dirigibles or hot air balloons. Do they still have those? Not hot air balloons, regular. Do they still have helium balloons?
Yeah,
helium balloons. You go to a store, you want a balloon that floats. That's a helium balloon, and lithium is the 3rd lightest. So here is another example. Can you count how many positives there are here? 1, 2, I only see 4 of them, but count the electrons. 1, 2, 3, 4, 5, 6. So there must be 2 more protons in here that we can't see that are behind them. So it has 6 protons. Let's see, 1, 2, 3, 4, 5, 6. That's carbon. And if you'll notice, Here it says carbon, that's the atomic number, that tells you how many protons. And it has 2 electrons that are closest to the nucleus and 4 electrons that are a little further away. Now, some people don't understand periodic. Now, periodic, if you go to the library and you ask for periodicals, you're asking for magazines that come out once a week or once a month or once every 3 months. They come out on a regular basis. And so these are elements, and they're periodic because every time you get to the end of a row, you start another row, and there's 1 electron in the outside circle. And that's what periodic means. It's just, it's happening regularly. You get to the end, start a new row, and there's 1 electron, 2 electrons, 3 electrons on the outside level, and so on. Here's one. This has 17 protons. So let's see, 17 protons. That would make this one, that would make it chlorine. Now that's about all we're going to do. I just want to point out one more thing about the periodic table, and that is everything that you see that my hand isn't covering up, all of these things are metals. And these are not metals. But you can see how almost everything, almost all elements are metals. So that's pretty much all I wanted to do with the periodic table, and let you know that these are all elements. Some of them you know of. You know about iron, and you know about copper, and you know about gold and silver, and you know about carbon and oxygen. That's the stuff you breathe in. Okay.
We have a quick question from Shane. He asked, is that picture of the atom, is that to scale?
No, it is not. That's a good question. So what happens is protons and neutrons have about the same weight or mass. But these little electrons, they are really, really tiny. Now, if you blew up a real atom, now remember, atoms are incredibly tiny. If you blew up a real atom and you made it the size of a baseball stadium, that's really big, right? So the nucleus, the part with the protons and neutrons, would be like a little marble behind second base. And these electrons would be pieces of dust flying around the outfield. So electrons are much, much, much smaller. If you want a number, they're 1,800 times less mass or weight. And they're very tiny. But most of the atom is empty space. Most of the atom is made up of empty space. Okay, now sometimes you'll have an atom, let's say this is an atom, and this is another atom, and they'll combine. And when 2 different atoms combine, that's called a compound, like good old water. Water is hydrogen, 2 hydrogens, and 1 oxygen, H2O, and that makes water. And that's a compound, 2 or more. Now you could have 3 of them together, or 2 of these and 1 of those. You can have lots of different combinations. There are gazillions and gazillions of different kinds of compounds. Okay, so here's an example of atoms. Here's a carbon atom. Oh, and look, you notice how some atoms are bigger than others. Carbon atom is bigger than a hydrogen atom, and an oxygen atom is bigger than a hydrogen atom. Now here are examples of compounds. Carbon dioxide is a compound. That's the stuff you're breathing out. And this is a type of alcohol called ethanol. It's made up of 2 carbons and 1, 2, 3, 4, 5, 6 six hydrogens and one oxygen. So there are lots of different kinds. There's one other thing I want to tell you about before we get into doing some experiments. And that is, sometimes you can have two elements together, two atoms together that are the same. And that's called a molecule. It's not a compound. Now this would also be a molecule, okay? But if you have two of them together, they're not a compound, but there are two of them, so it can't be an atom. They're called a molecule.
Like 2 oxygens is an oxygen molecule, then 3 oxygens is ozone.
Right.
So you can have a lot of different combinations.
Exactly. So what we're going to do is we're going to talk a little about acids and bases now. So acids and bases are kind of chemical opposites. They talk about acids and bases right here. And so you're familiar with a lot of these things, whether you know it or not. You have stomach acid in your body, right? That's the type of acid. You have vinegar. Vinegar is an example of an acid. This is, you've all tasted vinegar and maybe in salad dressing or something like that. And then you have other bases like ammonia. That's a really smelly cleaner that people use to clean their house, or other bases, citric acid that's in oranges and lemons and that sort of thing. And yeah, so that's another example of an acid. So all acids, can you see this at the bottom here? All acids have an H part of it. And the other part of the acid, we call an A here, but the other part of the acid, you can have HCl and HNO3 and lots of different kinds of acids, but they all start with an H. Now bases, you know, if you've ever picked up soap, you know soap is kind of slippery. That's because part of the soap has an end that's a base, and bases are all slippery. So here's an example from the book of a base. It has an OH. And so we're going to do a little experiment right now. Could you give me the So this is a chemical that is, let me take the top off. This is a chemical that's colorless. There's no color there. But if I take a base with a yellow cap, sodium hydroxide. Yeah. So here is a base. So when I put, and the base is also colorless. So when I mix these two colorless liquids, whoa, it turns this purpley kind of color. So that was called an indicator. An indicator is something that shows you something when something is happening. So this chemical, this little chemical is an indicator because it indicates when you have a base. And if I took an acid, so now I'm going to take some hydrochloric acid. This is the same acid that you have in your stomach to help you dissolve food. And when I add enough of it, there's no more purple. There's no more base. So what happens is the H from the acid combines with the OH from the base to form H2O, good old water. Here's a picture of it. If I can find it. Let's see. Here we go. So here you can see the hydrogen and the oxygen are combining to form water. Here's another picture of it on the middle of this page. Hydrogen and oxygen combining to form water. And then the other part of the acid and the other part of the base become a salt. So Diego, I'm going to ask you to pour this into the test tube.
Okay.
And then I'm going to light this. There's a little burner here. Thank you. Now, when you hold the test tube, you don't want to hold it here, because if you hold it here and you get a little excited, you could squeeze and that could happen. You always hold it at the end, because no matter how hard I squeeze, it's not going to fall off. And if you'll notice, I have it pointed away from me and from Diego and from James, because I don't want anybody to get hurt. So I'm going to heat up this. Can you hear it? We're going to heat that up. And when we do, the water is going to evaporate and come out the top as steam. Can you see it coming out the top? That's the water coming out. And what we're going to be left with is salt. So any acid combined with any base gives you a type of salt. This type of salt happens to be the kind you put on your French fries. Some salts are different colors and some salts are poisonous. So you don't want to, just because something's a salt doesn't mean you can eat it. There's only one kind of salt we can eat.
All right, we'll go with a couple of questions here while that's boiling.
Good, David, would you?
Yeah, sure.
Sarah asks, isn't that also a chemical reaction?
Exactly. When you have two chemicals and they combine and change, that's a chemical reaction. Now, if I take water and I freeze it, it's still frozen water. Or what's coming out of the top there, that steam, that's still water. It's just in a gas form. But when you have two chemicals coming together and they change, like the acid and the base, making salt and water, that is a chemical change.
And we had Abel ask, I don't really get what a base is.
Oh, so a base is a name for a certain type of chemical that has an oxygen and a hydrogen at the end of it. Here's an example. This is a base. It is made up of sodium and it's made up of hydroxide. Hydra for the hydrogen, oxide for the oxygen. And so this is a base. Sometimes if people have heartburn, they'll take Tums or Rolaids or something like that because that's a base. Or various other things that people take for heartburn. Heartburn is when there's acid in your stomach and sometimes it feels like the acid is coming up your food pipe. And so what happens is you neutralize it. You take this base that's safe to drink or eat, and that neutralizes and forms a water and a salt, so it's not irritating. Okay, we're halfway done here.
Marty, if you'll hold this, I'm gonna grab a demo kit, because one thing I learned in chemistry in college, I didn't really clear up the misunderstood on acids and bases until I was in college, but what really helped me is a demo.
Okay,
I'm gonna go with this model. Model.
there's one right here.
Oh, actually, I'm looking for the
Model kit is in the third drawer.
And one last question. Ariana asks, are we going to explode something?
Well, are we going to explode something? Yeah, I think we could explode something. I'm planning on exploding something.
Yay.
So we're almost done boiling this off.
So here's one way to explain acids and bases that I think might kind of shed some light on this. This, if we call this an oxygen, and these are two hydrogens, this is H2O. So that would be known as water. So if you have extra hydrogens in a liquid, things turn into an acid. If you have more of these OHs, then it's more basic. So you have and this is called hydroxide, which is an oxygen and hydrogen. So when you have higher concentrations of oxygen and hydrogen, it's considered, it's more of a base. When you have more just these hydrogens that want to bond, these extra hydrogens, it tends to be more of an acid. So that's one way to explain the acid-base chemistry. You have anything else to add?
Sure. Actually, I think what I'm going to do is ask you to go to the burners over there, the Bunsen burners,
Okay.
and finish that off. And I'm going to take this. So this would be an example of a base. It's a chemical with a hydrogen and oxygen right there. And this would be an example of an acid. It's a hydrogen with something else. And when these two come together, what happens is they switch places. And this comes off and goes here to form water. If I can get that in. That forms water. And this goes in here to form a salt. And Diego will have that salt here in just a minute.
Sarah asks, when you eat, are you causing a chemical reaction inside your body?
You are, because the chemicals inside your body, the acids in your stomach, even the saliva in your mouth start to break down these things you're eating so that your body can use it. And here, thank you, Diego, here, what is that white stuff? There's no more liquid left. That white stuff is salt that we made by mixing the acid and the base together. Thank you, Diego.
Sure.
Now we're going to do something exciting. Sorry about that. So here are eggs, and you know, I've forgotten which ones are hard-boiled and which ones are regular. And I sure don't want to have a surprise by, you know, opening one up and finding it's the raw egg. So here's the way to tell the difference. If you spin an egg and it spins like that, it's hard-boiled. If you spin an egg and it barely wants to spin, then it's raw. Another thing about eggs is, I'm going to ask you to crack that.
Okay, let me do the check. Okay,
Do
this
the
is
check.
practical. I didn't want any practical jokes by Marty. You want me to de-shot?
Yes, and you could put it over in here.
Okay.
While we're waiting for that, I'm going to put a couple of these in the bottom. While we're waiting for that, we're going to do this
Shot
experiment.
goes in here?
Sure. So here, I have some red cabbage juice. And I got this by taking red cabbage that you can get at your supermarket and chopping it up and boiling it in water. And then after you cool it down, it'll be this color. And so this, remember we talked before about an indicator? Red cabbage juice is also an indicator that you could make at home. And then you could try things like, let's try a little vinegar. Diego, I'm going to have you put in a little bit of the ammonia.
I have a quick question about the egg. Arabella asked, why is there a difference in the spin after you boil it?
Because the hard-boiled egg, ooh, look at that. That
Something
turned
happened.
green. Now I'm going to try a little of this in here. Let's see what happens here. It turned redder. So this is an indicator also. So the reason the hard-boiled egg spins so well is because it's solid. Okay, the egg that isn't hard-boiled, that's still liquid, you spin it one way and some of it goes this way, and then you're spinning the other. It needs to stop and spin the other way, and it's sort of a liquid kind of a thing that you're trying to spin around. And so it's difficult to get it to all spin around. But if you have like that, But if you have a hard boiled, this is a solid, so it just spins around easily. Another thing about eggs is if you're not sure if your eggs are still good, what you could do is take it and put some water in a cup and put the egg in the water. And if the egg floats in the water, throw it out. If the egg sinks, it's still good enough to use. So Diego got this hard-boiled egg, peeled, and now I'm going to take one of these and put it in here, and one of these and put it in there. Would you like that for me, Jason? There we go. So it was my birthday last week. No, but so what we're going to do is we're going to take this and we're going to put it inside here, and there's nothing in here but air, and we're going to see what happens. We're going to try that again. But you see, did you see it sinking down? Let's try the other one. I probably should have done it like that. Well, we'll make egg salad later. A little messy, but I got it. So we're going to try it again. Okay. There we go.
Even sucked up.
Sucks it up. So the reason this happened is because the, why did this happen, Dee? I'll give this, throw this over to you.
Sure. So we have gas expanding in there. So you're making a place that is hot, that has hot air. So it pushes all the extra air out. And then once the flame goes out, the glass cools the air down in there. And then there's an automatic vacuum created. And then you have it sealed really good because of the soft egg, and it gets sucked up.
Thank you, Dee. Didn't mean to put you on the spot there, but
no problem.
I thought you could handle it.
Yeah.
Okay, so now we're going to try an experiment with, we're going to do this one.
Okay.
So let's bring that over, yeah. So this is some yeast. So what I did is I have some warm water, and I put the yeast in here, and then this is like the powdery yeast that you get for making bread or something like that. And here is some hydrogen peroxide that you can buy at the store. Now, I added a little extra concentrated hydrogen peroxide, so it gives us a little more of a reaction.
And peroxide, when it's really concentrated, like 90%, it's rocket fuel. But at 3%, it's more antiseptic.
Yeah, it kills germs.
Yeah. Yeah, it kills germs.
So I'm going to put that in here. And now I'm going to add a little of, this is just dishwashing soap, dishwashing liquid. And now when I put this in here, now I'm going to take the yeast, and when I put the yeast in here, it should combine with the hydrogen peroxide and give off oxygen gas and foam and bubble up, and let's see what happens. Can you see it okay?
How's that look, James? Can they see it pretty good?
Yep. Yeah, can you see the bottom of it?
Pretty much.
Pretty much?
Yeah, oh, there we go. That's good.
Good. Now I'm going to pour this in. And there it goes. So this is sort of like the experiment with vinegar and baking soda. It's similar to that, but this is just making lots of bubbles. So these bubbles are bubbles of soap and oxygen. I wonder what happens if I would do this. No, you can't see much there.
It was worth a try.
It was worth a try. Would you get me Actually,
plastic bag.
no, I think
Bring it there.
that's why I did it in here. So I'm going to let you, put that over there.
I'll keep monitoring.
Let's see if we can try. I'm going to show you this. So this is just a plastic flower that I got at the store. And then I put some of that chemical on it that turns purple in a base. So when I take some ammonia and I spray it on, it turns purple.
This is clear before. It's nice.
Yeah, and this is clear also. This is vinegar. And so this is an acid and a base combining to form what? Salt and water. And so that's what happened. Now, let's see what else we can do.
I had a follow-up question on the egg thing. What does it mean that if one egg sinks and the other one doesn't? Or why does the bad egg floats, good egg sinks work?
Well, I think some of when an egg is fresh, it does sink to the bottom. When it's been around for a while, I think it makes
Gas. It's starting to decompose.
It decomposes and it makes a gas, and so that makes it a little lighter, just enough to float. Now, let's see, we sort of promised to sort of explode something, didn't we?
What are we doing here?
Good. So why don't I do that? In the meantime, let's see. Let's do that. I'm going to get some things together here.
And we can handle questions, or I can build some molecules.
Diego, while Marty's grabbing the stuff to make the boom, could you show us again real quick the combining of these substances here, the indicator with the vinegar, the indicator with the ammonia, the ammonia to create these different colors here? Is it possible that we could do that again momentarily?
Sure. So, and again, this is something that you can do at home. This is if you have cabbage, so you'd have to have some red cabbage, and you can just boil your cabbage a little bit, and you'll get the acid base indicator here. So let's see if I have glass here. Well, I have some indicator that was here.
I can rinse those out for you really quick.
Sure.
Yeah.
All right.
Thank you.
Thanks.
Okay.
And I'm going to do some molecule builds. So what is this? If you're at home, this is oxygen and 2 hydrogens. That will be H2O. And when we have these guys getting away in a solution and we get lots of extra hydrogens, when we get lots of extra hydrogens forming, we end up getting an acid. Because they pair up with other waters, and then you end up getting hydronium, a molecule called hydronium, and that makes more acid. When you have oxygen and hydrogen by itself, that is hydroxide. So acid base. Learning the difference between acids and base, it's good to go over that definition because it comes up so much in chemistry. And so the sooner you can get a grasp on that, on those definitions, the better you'll do in chemistry.
Okay.
All right. So with the experiment with the cabbage juice here, Sarah asks, is the ammonia the indicator, or is the cabbage juice the indicator?
The ammonia is the base, and so the cabbage juice is the indicator. The cabbage juice is the indicator. Cabbage juice is what's going to undergo a change. So it doesn't really take place in the reaction. It just indicates. It's like our for chemistry, it's like our it's a meter. It tells us what's going on in the solution. It's not really interacting so much with the chemical reactions. What's going on is you're having ammonia, which is giving you your hydroxide. So we'll go. Thank you. So I have some cabbage juice here, and we're going to put a little bit of this in here. And so this is our cabbage juice indicator. And again, this is vinegar. So any predictions on the color? and we get a little more pink, right? We get a little more pink. And then if we put some more cabbage juice again, here's our cabbage juice. And then we add something that's more basic, like our ammonia. We add that in here. And we get our green.
Okay.
So that's our acid base indicator again.
Good. So here's some hydrochloric acid. It's a kind of acid that you have in your stomach. And this is the metal magnesium. Now, magnesium reacts with hydrochloric acid. And you might see some bubbles here. So these bubbles are bubbles of hydrogen gas. And hydrogen is the lightest element, and it's the first one on the table of the elements, and it explodes. Do you feel that getting warm, Diego?
Oh yeah.
This is, I'm going to teach you a $5 word. The word is exothermic. Exo like exit, therm like thermometer, heat. So this is exothermic. It's letting out heat, just like a match. If you light a match, that's also exothermic. So Diego, I'm going to ask you to light that. And let's see what happens when we take this hydrogen gas and put it right where my thumb is. Whoa, did you see that? It exploded. Not only that, do you see this at the top of the test tube? Do you see that moisture? That's water that we made by combining the hydrogen gas with oxygen to form H2O. And there might be a little more. We're going to try this again. If we can.
Yeah. Let me see if I can.
Let's see if there's a little more in here. Let's see if we have any more hydrogen. There you go. Remember, it'll want to come up to the top. Whoa, little one. Okay. And we'll put this in here too. Now, we're going to do one more thing. So here's our peroxide. And I'm going to put this in here. Now we're going to do a test. I just had blue food coloring in there.
We have 3 minutes left.
Okay, this won't take long at all. Get a couple of splints still.
Okay.
Now this is a chemical. And get another flask. Splint should be in the second drawer. Get another flask also.
Okay. Another flask?
Yeah. So I'm going to put this chemical in here and like that. And put it in there and, okay, let's try again. There we go.
Flame on this?
Okay, blow that out. Put it in. There we go.
Whoa, so cool.
So this is oxygen gas that we made and sprayed all over James and myself. But that's the fun of doing chemistry.
Yep. Just ignites instantly.
Let's try it again.
So you can see how oxygen just totally ignites something.
Yeah, so this is oxygen. We made that gas that you saw bubbling up and coming out all over my hands and a little all over James is oxygen. This is a test for oxygen. If you put a glowing piece of wood in there and it ignites, it proves the gas is hydrogen. Before we had hydrogen gas And the test for hydrogen gas is you put a lighted piece of wood in there and it goes pop and ignites with a flame. Do we have any more questions, James?
All right, is that chemical likely to be in trick candles?
There is a chemical in trick candles, but it's usually magnesium. Magnesium is the chemical in trick candles, and it's also the chemical in sparklers. Okay. Okay, so thank you for joining us again today. And remember, curiosity is the cure for boredom. So stay curious about how the physical universe works, and we'll see you again next time. Bye for now.
Bye-bye.